All right, let's dive right in. Today, we are getting up close and personal with an absolute workhorse of the power generation industry, the PG9171E Gas Turbine. Look, if you're serious about a career in this field, knowing this machine inside and out isn't just a bonus, it's a must-know. So let's get you ready to master it.
Okay, picture this. You're in the interview. This is it. The technical question that separates the people who've kind of skimmed a manual from the ones who really get it. Your answer here has to be sharp, confident, and, precise. And here's the secret. It doesn't start with pushing a button. Nope. It starts way before that. Before you can even think about starting the PG9171E, you've got to respect the sheer scale and complexity of what you're dealing with. I mean, this is not your car's engine. This is a massive piece of precision engineering, basically a controlled explosion designed to spin at incredible speeds. And these specs, they really tell the story. You've got a 17-stage compressor cramming unbelievable amounts of air into 14 combustion chambers. That power spins a 3-stage turbine at a blistering 3,000 RPM. But here's the kicker. Just to get this giant moving from a dead stop, you need a 1,000 kilowatt starter motor. That's like the engine of a locomotive, just for the initial push. These numbers are the bedrock for every single step that comes next.
So, let's get back to that interview question. The very first thing you say shouldn't be about the startup sequence itself. No, the first thing you do as a professional, responsible operator is the pre-startup inspection. You physically walk the machine. You check everything. This is priority number one. This checklist is basically your script. Before you touch a single control, you're out there confirming that every system is in its ready state. Are the power breakers set to auto? Are the fuel valves shut tight with absolutely no leaks? Are the backup lube oil pumps ready to go in standby? You're making sure the machine is safe and ready before you even think about giving the start command. This shows you're thinking ahead, putting safety first. Okay, so your pre-flight is done, everything's checked out, now you're ready to tackle the main event. Let's walk through the launch sequence. Starting up a PG9171E isn't just one action. It's a super carefully orchestrated series of phases, and each one has these critical milestones you have to hit. This right here is the perfect framework for your answer. It's simple, it's logical, and it's easy to remember. Purge, ignite, accelerate, and synchronize. First, safety first, right? You purge the whole system of any leftover fumes. Then you get ignition. The spark plugs fire and you get a positive confirmation of a flame. After that, the machine starts to accelerate all on its own. And finally, the last step is to synchronize with the power grid. Nail these 4 phases and you're golden. Now, during that acceleration phase, there are 2 numbers you absolutely, positively have to know by heart. The first huge milestone is this one. 60% of full speed. So what's so special about 60%?
Well, here's the deal. At 60% speed, the turbine becomes self-sustaining. It's making enough power to keep itself going. That massive 1,000 kilowatt starter motor, which you might know by its device number 88CR, has done its job. It just disengages, and the turbine is now pushing itself the rest of the way up to speed. It is a huge moment in the startup process.
But we're not done yet. The turbine keeps accelerating. The next key number you've got to have locked and loaded in your brain is 95%. This is the signal that you are right on the doorstep of full operational speed.
At 95%, for all intents and purposes, we've hit full operational speed. Now, the main turbine shaft is spinning fast enough to power its own essential gear, like the main lube oil pumps. This means the electric auxiliary pumps, like device 88QA, can take a break. The machine is now stable, it's self-sufficient, and it's finally ready to connect to the grid. So, you're synchronized, you're loaded up, and the startup is officially complete. But your job isn't over, not even close. It's just shifted gears. Now you go from this active sequence of events to a state of constant, vigilant monitoring. You are the guardian of hundreds of critical data points.
And I mean, just think about this. Take just one of those hundreds of parameters, lube oil header temperature. As long as it's below 76.6 degrees Celsius, everything's fine. The system is stable. But the second it ticks over that line, an alarm goes off. It is your job to know exactly what that alarm means, why it's happening, and what to do about it. It's a job of total precision and non-stop attention to detail.
Of course, what goes up must come down. Every flight has to land. And shutting down a gas turbine is just as methodical and just as critical as starting it up. It's a controlled process designed to protect this incredibly expensive machinery and make sure it's ready for the next time. The shutdown sequence is pretty much the startup in reverse. You gently unload the power, you disconnect from the grid, and then you cut the fuel. The flame goes out, and the massive turbine begins to coast down, just spinning slower and slower from its own momentum. But then, as it gets really slow, something incredibly important happens.
Okay, so the machine has finally spun down from 3,000 RPM. The control room is getting quiet. The interviewers are looking at you, waiting for you to wrap things up. Is this it? Is the process over? Is your job done?
Absolutely not. And this right here is the final point that shows you think like a real seasoned operator. The job is not done. The turning gear, or 8ATG, kicks in. It's this small motor that engages and just slowly, constantly rotates that massive hot rotor. Why? Because this prevents the top from cooling faster than the bottom, which would actually cause the multi-million-dollar shaft to bend or sag under its own weight. Protecting that piece of equipment is your final, ongoing responsibility, and that is how you